Video of AP Stat. Today we're going to be talking about how you display all of this quantitative data that we've been gathering. So to start off with our display of quantitative data, we're going to talk about dot plots. In your notes, I gave you a data set that listed the number of goals scored by the U.S. women's soccer team in 34 games during the 2004 season. So we're going to make a dot plot to represent the number of goals scored. Here's what it looks like. Dot plots are very common. We see these a lot. And you can see across the bottom we have a label, goals. And you can see very quickly the range from 0 to 8. 8 was the maximum. 8 only happened one time. 0 happened one time. And the one that happened the most was 1. It happened 8 times. So dot plots are very common. One thing I'm missing here is I am missing a title, which I told you in the last video. You should always include a title. But you can see that this is a great little dot plot to help you see what's going on with the U.S. women's soccer team in 2004. Take a minute to copy this down in your notes. If you need to, press pause. But if you have it all written down, then we're going to move on to the next one. Stem plots, also referred to as stem and leaf plots. We use these stem plots with univariate, meaning one variable, numerical data. Always include a key so that you know how to read the numbers. So I gave you a data set that listed Barry Bonds' home runs. We're going to draw a stem plot that represents the number of home runs hit by Barry Bonds, and here's what it looks like. So you can see that he hit a number of home runs in the teens twice. He hit 16 one year and 19 one year. In the 20s, he did that 3 times. In the 30s, he did that 6 times, as well as the 40s. And then he had 1 year that was really good where he hit 73. And so you can get an idea of what's going on. Notice that in the stem plot, I still included the 50s and the 60s, even though he never hit anything in that range. You want to include those so that you can see the gaps. Sometimes when you're comparing two scores, for example, here we have 9th grade quiz scores and 10th grade quiz scores. If you have two scores, we can do a back-to-back stem plot, which would look like this. People sometimes get confused about this. They're not sure what they're reading here. One thing to pay attention to is that first 9th grade, that 6 and that 1, that's not 61, that's 16. The stem is 1 and the leaf is 6. So you have to read the 9th grade backwards. So it's not 94, it's 49 when you're reading that. The 10th grade, they're written in the proper order, so you don't have to do the same thing for that one. Another thing you sometimes have to do with stem plots is if you have data sets that are lots of data, so there's lots of 20s, lots of 30s, lots of 40s in this set, we split them up. So the first stem, that's a 2, is the lower 20s, and then the second stem is the upper 20s, and then the lower 30s and the upper 30s, and so on. We do this trick when you have really big data sets. Again, if you need to press pause, take a minute to copy these things down before moving on to histograms. A histogram. Now, a stem plot represents the number of data points found in a range. For example, the 20s, the 30s, and the 40s. Stem plots, the ranges are kind of set. We can't really do a whole lot with them. They're the 20s, the 30s, and the 40s. Maybe you can split them up, but you can't do as much. A histogram, same general idea, but histograms are more flexible. You can have wider ranges, shorter ranges. You can do pretty much any kind of range you want. The one thing you do have to be careful about is the ranges do need to have an equal width. Histograms in certain respects are less useful than stem plots because you can't see the actual data of a histogram. For a histogram, you just see general ranges. You can't actually see the data, unlike a stem plot where you can see the actual data. So they have their uses, and sometimes they're a little deficient in that regard. I gave you a data set on temperatures. I gave you a data set with daily high temperatures of Poughkeepsie, New York for the month of September. It looks like this, nice big data set. If we want to make a histogram out of that, here's what it would look like. Take a minute, write this down. So you notice we have across the bottom, we have temperatures. Oh, let me go back a minute. And then we have frequency on the left-hand axis, and we have a title up top, temperatures. Notice that the ranges for this histogram, the bars are touching, the ranges are all 2. So the first box is from 65 to 67, and then from 67 to 69, and then from 69 to 71, and so on and so on and so on. If you need more time, press pause, but you want to make sure you write this down as an example before moving on. How do we describe a numerical graph or univariate graph? Lots of words here that you're going to want to write down. Bimodal, or sometimes referred to as multimodal. Bimodal refers to data in which 2 or more classes have the largest frequency, and they're separated by one other class. Here's what a picture of a bimodal would look like. It has two humps, kind of like a camel. So it's got two, that's where the bi comes from. You can have one that's got more, it's got 3 or 4 or 5 humps, but that's a picture of what the bimodal would look like. You don't need to copy down the data set, but you should copy down the picture. Uniform is another word we use. Uniform, we refer to data in which every class has equal or approximately equal frequency. So what do I mean by that? Well, here's a picture of a uniform data set. Pretty much everything's the same. It's just a straight flat line. The 10s, the 20s, the 30s, the 40s, they're all the same. They're all uniform. Next up, symmetrical. Symmetrical refers to data in which both sides are more or less the same. If you fold the graph down the middle, it's going to look the same on the left and the right. We sometimes refer to symmetrical as a bell-shaped curve. So a bell-shaped curve has a center mound with two sloping tails. Here's an example of a bell-shaped curve or a symmetric curve. And then finally, skewed. This is a very common one, left and right skew. It refers to data in which one side, we call the sides tails, one side's longer than the other side. And when we talk about left or right, we're always talking about the direction is the side of the longer tail. So let me give you an example. We have two different types of graph here. One of them is left skewed and one of them is right skewed. The first graph there is an example of something that's skewed to the right. The longer tail is to the right. So you always want to do in the direction of the longer tail. Whereas the other one, the one on the right side, is skewed to the left because the longer tail is to the left. We're going to ask you to use these words, so you're going to be familiar with these different types of words. So one of the most common things you're asked to do is you're asked to compare distributions. If I give you a set of dot plots, or a dot plot like this one, this is 3 different dot plots with 3 different classes, A, B, C. I might ask you to compare them. When you're asked to compare distributions, you want to look for what are the differences between them. Well, for these particular groups, the thing I notice is that the center is different for each one. If this is an exam score, Class A did really well. Their center is up around 81. Class C did really badly. Their center is down around 60. So you always want to make sure that you talk about the center of a data set. When we're talking about the center of a data set, we're talking about where's the middle. Where's the middle roughly, approximately, where's the middle of the data set? There are 3 types of central tendency. There's the mean, the median, and the mode. That's pretty much the 3 you need to worry about. The mean is the average, the median is the middle, and the mode is the one that happens the most. So when we're talking about center, talk about the mean, median, and mode. Next up, what do you notice about this dot plot? When I look at this dot plot, I notice that there's a big clump of data in the middle, but then there's 2 little points on the outsides. So this is an unusual data set, and I want to make sure I talk about what's unusual about it. So you want to talk about unusual occurrences, the outliers, the gaps, the clusters, anything else unusual about that data set, right? So we always want to talk about unusual occurrences. Here's another example. This example says, what do we notice about these 3 dot plots? Well, I noticed that the first dot plot F is really spread out, whereas D is very grouped together. So I'm looking at the spread. How spread out are these different things? D is much less spread out than F, and E is spread out somewhere in the middle. So we want to talk about the spread. Discuss how the spread out the data is. When we talk about spread, we talk about variability. How varied? What kind of variability? How varied is the data? We want to talk about the range, the standard deviation, the IQR. Those are things you want to talk about when you talk about spread. And then one last thing, what strikes you about these classes? I, H, and G. This one's a little harder. The centers are a little different, but I'm really noticing that in I, that's the shape. It's skewed to the left, whereas in H, it's skewed to the right, and G is symmetrical or bell-shaped. So we want to talk about the shape. What shape does the data take? Is it symmetric? Is it skewed? Is it bell-shaped? Is it symmetric? We want to talk about these things. Are there any gaps? So in context, finally, when we're talking about describing a distribution, you always want to talk about it in context. You want to be specific. You want to use correct statistical vocabulary, and you want to use complete sentences. This is a writing class in this respect. So you don't want to shorthand it. You want to make sure that you be specific. Now, here's a nice little phrase that'll help you remember it. Cuss and BS. Whenever I ask you to describe a distribution, I'm giving you permission to cuss and BS. Cuss is center, unusual occurrences, shape, and spread. That's what it stands for. BS, be specific. So when you're talking about distributions, cuss and BS, center, shape, spread, anything unusual, and be specific.
That's all, folks.